Okay, we've got some bricks with three different dimensions because they're cuboids essentially with these three dimensions. Correct to one decimal place. A house is built using 4,663 of them. And Jocelyn says if we place them end to end, they would definitely reach over 1 kilometer. Show that his statement is correct. Now, what this question is assuming is that end to end is like this, with the longest length lined up together. Why it couldn't be the shortest length lined up together, I don't really know, but that is what they're looking for. So I'm not really a big fan of this end-to-end comment. But anyway, let's roll with it. So we've got these 4,663 bricks. We are lining up the longest length together. So I've got 4,663 of these lengths. But I basically want to find the minimum length that could be. And that means to use the lower bound, which is 21.45, because that will round up to 21.5, but a number less than that will not. So why again am I using the lower bound? Because I want to get the minimum, and I want to show that that minimum is more than 1 kilometer, because that will mean it's definitely over 1 kilometer. Because it could be that the upper bound is more than 1 kilometer, but the lower bound is not, in which case it wouldn't definitely reach over 1 kilometer. So that's why I'm using the minimum. I'm going to do 4,663 times 21.45. Okay, then I'm going to work that out. And I get 100,021.35. Okay, meanwhile, 1 kilometer is equal to 1,000 meters. 1 meter is equal to 100 centimeters, so it's 100,000 centimeters. And so I can say that this is more than, I think I'll go with 100,000 centimeters. This is more than 100,000 centimeters, 1 kilometer. Jocelyn is correct. Okay, part B, a standard brick should weigh 2.8 kilograms, correct to one decimal place. A truck can carry a maximum load of 20 tons. Now we've got kilograms and tons, so I'm immediately going to change this to kilograms. 1 ton is 1,000 kilograms, and so this is 20,000 kilograms. Calculate the maximum number of standard bricks that the truck should be able to carry. Now it's this should be able to carry that is kind of the key bit of this question. It's not like the maximum possible number that we could get away with potentially, and that would be to use the lower bound. It's that the maximum number of standard bricks that the truck should be able to carry. So actually we are going to use the upper bound of this 2.8, which is 2.85. Yeah, I think this is quite a confusingly worded question, but it's like we need to be safe, basically. We don't want the truck to break, and so it's the maximum number of bricks that the truck should be able to carry. So if we use the upper bound, we can be sure that it can carry those. Then we do 20,000. That's the total number, the total weight that can be carried divided by the weight of one brick, but the upper bound of the weight of one brick. That gives us 20,000 divided by 2.85, which equals 7017.5. 7017.5. And that means that we can definitely carry 7017 bricks, because like if we round it up to 7018, well, that could actually go above the 20,000 mark, and it could break. So we should be able to carry these 7017. Another reason I've realised why it says should be able to carry is that we've not thought about the volume of these bricks. So it could be that the weight is fine, but actually they just take up too much room. So that's kind of where that's coming from as well. So for part 2, explain why your answer to part B1 is not possible to achieve. It's one of these reasons. The truck may not have enough room or something equivalent to that, or maybe safety regulations may not allow it. It could be that the truck can carry it, but safety regulations say, you know what, you shouldn't risk it. Maybe the truck's a bit old and breaking down, and we don't want you to carry that many. So yeah, one of those two things to answer the last bit of the question.